Zinc plus silver nitrate. You remember? So
Yeah.
Zinc plus silver nitrate.
I got a photo.
Yeah, zinc plus silver nitrate
Silver. Yeah.
gives you what?
Silver plus zinc nitrate.
Silver plus zinc nitrate. You have an equation like this. Alright? What type of equation is this? Let me start with the type of equation. This is?
No, single.
This is single replacement. This is a single replacement. Why did you say this is a single replacement reaction?
Only one of them.
Because there's one metal here, zinc replaces silver. So this type of reaction is a single replacement reaction. Where is metathesis reaction? What are the conditions for metathesis reaction? You need to have what? You need to have two compounds. Two compounds, okay? Not like a single element in the compound. This is a single replacement, but if you have two compounds, compound A plus compound B, there is always a metathesis reaction, okay? So, now whatever reaction we have, reactions are not perfect, that's the bottom line. Reactions are not perfect. Like, we balance the chemical equation, we do balancing, okay? However, not all the reactants are consumed at the same time. All the reactants will not be around at the same time. Sometimes, unfortunately, one of the reactants consumed early or faster. One of the reactants stays longer. That's how the nature of the reaction is. So, as a chemistry student, that we need to find out which is the limiting reactant. What is the purpose of knowing the limiting reactant? That's the key part. Why we need to know a limiting reactant and excess reactant. What's the purpose of it? To get the maximum amount of product. You know, maybe like you work with the economist and you want to tell him, you know, how much product that you get. How much product you get is determined how much reactant you have, and is also determined what is the amount of a limiting reactant, because the limiting reactant always determine the outcome. Okay, always determines the outcome. So you know, there are infinite ways. Okay, I'm not saying that there's only one way. Pick, if you understand the concept, okay, pick which one is right for you. Just try to understand the concept. That's all I can say at this point. And try to understand, and then, you know, some of you can go straightforward method, some of you can go mass to mass relationship, some of you can go mole to mass, some of you can go mole to mole. I don't know which way is convenient for you. I will tell you the you know, the idea, the general principle behind it. In that regard, I think there were some values were given to you, right?
2 core of silver nitrate.
How many? 2
2
grams?
Oh.
2 grams, yeah.
2 grams of what?
Yeah, 2 grams of zinc.
2 grams of zinc is given.
2.5.
2.5 grams of
AG.
AgNO3 is given, right?
And you have to balance the equation.
I'm sorry?
You have to balance the
You have to balance the equation. Yes, you have to balance the equation. So how do we balance the equation?
You did it, and then it was 2.
No, okay. There was, but there was that. But how do you balance the chemical equation? That's my question. How do you balance the chemical equation?
I think we have to focus first on the polyatomic
Ion. Yes. If you have a polyatomic ion, give priority to the polyatomic ions first. Again, not necessarily, but it makes life easy for you. I have nitrates. I have 1 nitrate here, right? How many nitrates I have? 2. So simply I can put 2 here to balance the nitrate ion. Then go to the single ions. Okay? If you have a polyatomic ion, do the polyatomic ion first. It's not a rule, it's not a regulation, but it makes things easier. Okay? So if you look at here right now, I can put 2 here. Right?
Yeah.
So the equation is balanced. The equation is balanced. Okay, now Okay, what is the first question? Yes,
Excuse
yes,
me,
Beverly.
excuse me.
Go ahead, yeah.
The polyatomic ion is the AgNO3, the NO3.
No. The polyatomic ion is NO3, just NO3.
So you have 1 nitrogen and 3 oxygen.
No, I have one NO3. I have one NO3. This is a nitrate ion. You can't say one nitrogen and 3 oxygen literally, but in chemistry there is no nitrogen here.
Okay.
There is no oxygen here. Honestly, there is nitrate here. It is absolutely different from nitrogen and oxygen. This is a nitrate ion.
So you have 1 there and 1 there.
I have one nitrate here. I have 2 nitrates here.
For a total of 3.
Well, right now, 2 and 2, because the number 2 is for silver and the number 2 is for nitrate. So I have 2 nitrates here.
Okay.
And I have 2 nitrates here.
Okay.
That way the equation is balanced, right? The equation is balanced. So the first question was what? What was the first? Which reactant is limited? Which reactant is limited? A limited reactant. Okay. How do you answer this question? Which reactant is limited?
We find the atomic mass for zinc and then silver nitrate.
Okay.
And then you do crisscross.
Oh, okay. Kim said, find the atomic mass of zinc. I know the atomic mass of zinc. Zinc is 65, right? And what else?
And 2 grams on the bottom.
Okay. Well, let me see if this is good for you. Okay. Go ahead. Okay. You want me to put 2 grams of.
And then put the 65 on the bottom.
Here.
Yeah.
Okay. 2 grams of zinc. 65 grams of zinc. Okay.
And then find the atomic mass for the silver nitrate.
What is the atomic weight of silver nitrate?
It's going to be 340.
340. Okay. 340 grams of silver nitrate.
We need to find out if you have a 65.
Okay, hold on. Before that, are we okay with 340? How did he get 340?
2 times the
The molar mass of silver nitrate. Okay. Okay, so silver I believe has 107 or 108.
108.
108. And nitrogen has 14. Oxygen has 16. So all this together gives you 340. Because you have to multiply by 2. Okay. All this gives you 3.
I see how to be times 4. The oxygen.
Yeah. Basically, yeah. You have to multiply with the subscript times the coefficient, yes. But all together, when they add, it gives you 340. Does that make sense? Yes? Okay, go ahead now. Go ahead.
And you do the crisscross, you times.
Okay,
zero
well,
times.
I put X here.
Yeah.
Okay.
And then you find the X. You did like.
Okay, you do
multiply
crisscross, okay.
Multiply 2.
Okay, X equals to 2 grams of zinc times 340 grams of silver nitrate, right?
Yeah.
Divided by
65.
65, okay. Okay, crisscross, okay. And
And you'll get 10.46.
10.46 of what?
Silver nitrate.
Silver nitrate.
Right.
Gram, okay. And?
And you see like which one is going to be limited here.
Okay, which one do you think is a limiting reactant?
Silver nitrate.
Why?
Because when you have 2 grams of zinc, you need a 10.46 where you only have 2.5. So silver is the one.
Wait, I don't have the part understand.
Okay. What Kim's trying to say is, find out the limiting reactant. That's one way, by the way. One way, one approach. Maybe it might be easier, maybe it might be complicated. But we're going to look the other way. I would say this is easiest. That's my opinion, but I don't know. He's just comparing the given values. What he's trying to say is, you know what? According to the equation here, 65 grams needs 340 grams. That's what it means. 1 mole of zinc reacts with 2 moles of silver nitrate, right? 1 mole of zinc means 65 grams of zinc needs 340 grams of silver nitrate. Where do I get this information? I get this information from the equation given here. Okay, the equation tells me that every 1 mole of zinc stoichiometrically equals to 2 moles of silver nitrate. That is the significance of balancing equation. Well, I don't want to deal with mole because this is gram. This is quantities given in grams, so I have to change everything to grams. So 1 mole of zinc means 65 grams. 65 grams is stoichiometrically equals to 340 grams of silver nitrate. Okay, if that is the case, every 65 grams of zinc needs 340 grams of silver nitrate, according to this, what we have here. Then, well, if I have 2 grams of zinc, how many grams of silver nitrate I need? I do crisscross, okay? And then X gives me 10.46 grams of silver nitrate. Now, I have to start to think. I have to compare this value with the value just given here. Compare 10.46 grams of silver nitrate versus 2.5 grams of silver nitrate. And what is your conclusion from here? You compare 10.46 versus with 2.5 grams of silver nitrate. And what's your interpretation from here? You compare these two values and you have to come up with something. And when you see these two numbers, what do you see?
10.46 is bigger.
10 common sense. 10.46 is bigger. Yeah, that is true. But which means that if you have 2 grams of zinc, you need 10.46 grams of silver nitrate. That is the real, that's the truth. The 2 grams of zinc needs how many grams of silver nitrate? 10.46, because 65 grams requires 340 grams of silver nitrate. If that is the case, if I have 2 grams of zinc, how many grams of silver nitrate I need? 10.46. Unfortunately, though, I have 2.5 grams of silver nitrate. So it means 2.5 grams of silver nitrate is not enough for 2 grams of zinc. For 2 grams of zinc, you need, yes, for 2 grams of zinc, you need 10.46 grams of silver nitrate. But the guy, your supervisor, was greedy, maybe? He gave you 2.5 grams of silver nitrate. Okay? Is stingy, selfish, maybe? We don't know. But he gave you 2.5 grams of silver nitrate. It means, maybe he didn't know the accurate amount. It means these 2.5 grams of silver nitrate is a limiting reactant. But it's not enough. For 2 grams of zinc, you have to have 10.46, but 2.5 grams is not enough. Okay. Are we clear on this? Okay. If 2.5 grams of silver nitrate is a limiting reactant, everything is based on silver nitrate. The amount that is produced is not based on zinc. Now, again, I want you to go back with the idea of slice of cheese and bread. Slice of cheese and bread.
That way, that you're showing on the board is actually easier than what the book is talking about.
Okay. Well, you
The
know,
book's,
my point
the book's
is,
talking about going to moles from grams and then going back. Yeah,
it's
kinda
tedious.
easier.
Yeah, it's really tedious method. That's why, you know, yeah, it's very long. It's
Yeah,
very long.
sure.
Actually, you can follow it, but it's very long. And, you know, sometimes if you have a long process down to the line, you might make mistakes.
Yeah, I tried to give me like 10 minutes.
Yeah. You know, my point was to understand the concept. If you understand the concept, use whichever way you like, really. If you understand the concept, that's much easier. So now, everything is based on silver nitrate. So the first question was, which one is a limiting reactant? Now we know a limiting reactant is silver nitrate. Okay. What is second? Yes.
What about if you are like starting by finding the amount of zinc we need to to react to 45 silver nitrate.
You can
Like
do
it's
that.
going to be like
You can,
0.45 gram of zinc. How we can decide this is the limiting factor?
Okay, look. Because I think most of you understand the logic here, right? The logic behind it. Okay, yes.
Yeah, I do, but I just don't understand how we would determine, because I just thought that the zinc was the limiting reactor, because if it takes,
You say zinc
if
the
it
zinc is
takes
the limiting reactor?
10.40, what is that, 10.46 grams of silver nitrate,
Yes,
for 2 grams of zinc,
yes.
well, there's, I don't know.
No, let's do the other way. Don't worry, let's do the other way. Wait. Yeah. It means you understood it now, right? You got the point now. Okay. Let's say what Amanuel is trying to say here. You know, okay, forget zinc. Don't compare the amount of silver nitrate. I'll tell you another secret. Forget silver nitrate. And think about zinc. Is that what you wanted, right? Here is what I'm going to say. You know what? If I have 65 grams of zinc, right? 65 grams of zinc. How many grams of silver nitrate I need? 340. If I have 2.5.
Of zinc?
No. If I have 2.5 grams of silver nitrate, how many grams of zinc I need? Now I'm doing the vice versa. Let's see the difference.
We'll do the same thing.
Oh, well, no, it's not the same answer.
No, I'm saying
It's not the same
you'll
answer.
see like. which one is
Exactly.
limiting reactor.
X will be what?
0.478.
Well, 2.5 times 65 divided by 340, right? Which is
0.478.
0.48?
48.
48, whatever.
48?
Don't it have to be
Yeah.
20 certain amount of numbers or something?
I'm sorry?
Don't the big number
I'll
have to
put
be
it-
20 certain amount of numbers? Like, it can it be 0 point something, like the answer?
No, when you multiply this, 2.5 times
Yeah, I know
65.
that. I'm talking about, you said something before. and then I
That's
forgot.
significant figure?
Oh, that's for significant figures. That's when you write numbers in a scientific notation.
No.
What is it?
You said something one time that the numbers have to be between, it can't be over like a big number or something like
Yeah.
that.
It's the same.
The number of significant figures. Okay, so maybe you know, you have 2 significant figures, you have 2 significant figures, you have 3 significant figures. The final answer will have 2 significant figures.
Yeah, that's not what I'm talking about. But you can go ahead.
Okay, all right. Okay, we have 0.48 grams of zinc. Now, okay, I want you to compare this value, 0.48 grams of zinc, with the given value, 2 grams of zinc, and tell me what you think.
We're gonna have access.
We have
You don't have access.
Right.
Exactly.
Yeah.
Okay, compare the 2 grams of zinc, 2 grams of zinc with versus with 0.48 grams of zinc. And what is your interpretation from here?
The zinc is more than, yeah.
The required amount for 2.5 grams of silver nitrate is only 0.48 grams of zinc. This is excess. 2 grams is excess, but you have been given 2 grams of zinc.
So we
what's
don't need
the-
one calculation. It's enough to do one calculation.
Of course, of course.
So does the number have to be more than 2 zinc? Like, this was 2.5 and then it was equal to 10.46. Do it have to be a higher number is what I'm saying?
Well, the idea is whether you have 2.5 for 2.5 grams of, for 2.5 grams of silver nitrate, you need how many grams of zinc? If you have 2.5 grams of silver nitrate,
You only need
10.46, okay? 10.46. If you have 2 grams of, let's say, if you have 2 grams of zinc, if you have 2.5 grams of silver nitrate, you need 0.48 grams of zinc. This is the practical amount. This is the amount that you're looking for. This is what you have. What was given to you was 2 grams of zinc. So you make a comparison between 2 grams of zinc and 0.48 grams of zinc. So 2 grams of zinc is what? Excess. You need 0.48. You need almost half. 0.5, almost, right?
And this one, you use the 2.5 of silver nitrate, right?
Yeah, this way, still you use the 2.5 grams of silver nitrate is the excess reactant. I mean, the limiting reactant. The 2 grams of zinc is excess reactant.
So we don't have to like do the reverse like you just did over there
No,
to determine.
no.
Because well, if we just use one, if
That's
we just
enough.
go one way, we're gonna figure it out. Because
Exactly.
because if that was under 2.5 grams, then the zinc would be the limiting reactant.
Exactly, exactly. You don't need to do both.
Okay.
Just one would be enough. But but some people want to start from left to right. Some people want to start from right to left. I mean, whichever way is convenient. But like Emmanuel asked if he wants 2.5 grams of silver nitrate, how much zinc we need? I came up with a different idea. I wanted instead of silver nitrate, I want to calculate the amount of zinc and how many silver nitrates would I get. Both ways, anyway, the same.
So you're saying it doesn't matter which way we start, right?
Which
You're
way
gonna
it
say-
doesn't,
you're gonna say this.
absolutely it doesn't matter. You know, the limiting reactant is what? Silver nitrate. The excess reactant is what? Zinc. We answered the first one, but there is another question, I guess.
Yeah.
How many grams of zinc?
I'm sorry, the second question?
How many grams of zinc nitrate will form?
Oh, how many grams of zinc nitrate will form? Very good. How many grams of zinc nitrate will form? Okay, before I say something, can you tell me how you calculate this? How many grams of zinc nitrate can form now? How do you answer this question?
You use
Please
the
raise your hand, sir. Okay.
you use the limiting reactant, which is EGN3. Like you do 340 grams of EGN3 will give the molar mass of zinc nitrate. Then you compare it with what is it? 2.5
Grams of silver nitrate. No, okay, let me stop you there. Why you pick 2.5 grams of silver nitrate? Can you explain why? You're right, but I want you to explain that.
Because 2.5 grams of the silver nitrate is a limiting reactant, and it's going to finish before the 2 grams of zinc. So you
Yes.
have to use the smallest amount.
Yes. So in our case, how much how much zinc nitrate is produced, or how much silver is produced, is now from now on is depending on this, on silver nitrate, on the limiting reactant. So the second question actually was, what was the second question? How many grams of zinc nitrate is formed? Zinc nitrate is formed. So what I'm going to do is,
Zinc nitrate.
zinc nitrate, yes. Maybe I can take off this. I would say, according to the chemical equation, I have to go back with the chemical equation. I would say 2 moles of silver nitrate is stoichiometrically equals to what? 1 mole of zinc nitrate, right? According to this equation. According to this equation. Now, but we're not doing mole-to-mole relationship because everything is in mass, so I'm going to change 2 moles of silver nitrate into mass of silver nitrate. So 2 moles of silver nitrate in terms of mass equals to what? 2 moles of silver nitrate in mass will be 340 grams of silver nitrate stoichiometrically equals to what is the molar mass of zinc nitrate?
189.
The molar mass of zinc nitrate is going to be the atomic weight of zinc. Which is the atomic weight of zinc? Is 65?
65.39.
65. Okay, I'll pick the even number plus 2 times 14 plus 6 times 16, right?
Yeah.
That gives you what?
189.39. 190.
190. 190. Okay, you round it up, right? Okay. So that's 190 grams of zinc nitrate. So if I have 2.5 grams of silver nitrate, I need X amount of zinc nitrate. Okay? I pick silver nitrate for one purpose, because silver nitrate is the limiting reactant. So how much zinc nitrate is produced is depending on 2.5 grams of silver nitrate. So I do crisscross, which is X equals to 2.5 times 190 over 340. That gives me what? I'm sorry?
1.4.
1.4. 1.4 grams of zinc nitrate. 1.4. 1.4. This is the amount that you get from 2.5 grams of zinc nitrate. Yes?
If, for example, the limiting reactant was zinc, you will use 2.0.
Yes. Yes. If the limiting reactant was zinc, yeah. That is the main purpose. The very first thing, if you have a problem nature like this one, your goal is to determine which of the two reactants is the limiting reactant. Is it zinc or is it silver nitrate? Once you determine that, then everything is working based on the silver nitrate, the amount of silver nitrate you have. Okay. So the next one.
How many grams of excess reactant will be left at the end of the reaction?
How many grams of excess reactant will be left at the end of the reaction? That's a very good question. Who can answer that? Yes.
You would have to subtract. Okay, if the zinc is the excess reactant, then you would. I don't know.
Okay. And okay, go ahead. Okay, let's see.
Because we have said that it's 0.48 gram of zinc is needed for 2.5 gram of silver nitrate.
Yes.
We subtract 0.48 from 2 grams.
2 grams of zinc was excess reactant, right? But the amount zinc needed was 0.48 grams of zinc. So if I subtract 0.48 grams of zinc from 2 grams of zinc, what do I get? 1.52 grams of what? Zinc. This is unwanted. This is excess. Yes.
Can we use this one to find this?
Which one?
You know, in this one, we were looking for AGN.
Well, here we already did this one. Yes. We did this one because if once you know that silver nitrate is your limiting reactant, right? So common sense, the excess will be the other one, right? Right? Yes.
But see, you just told me that we didn't have to do it reverse.
That's what I'm saying. So that means
So then we have to do it reverse to find out the.
For the third one. See, for the first one, to determine which one is the limiting reactant, one would be enough. Now, you see, the question it has 3 components. This question itself. Now, the third question, unfortunately, asks you, well, which one is the limiting? Which one is the, how much is the excess reactant? Then you don't have any choice. Now you have to do it. I said to you in the first hand that in order for you to determine which one is a limiting reactant, of course one way is enough. Maybe this is enough here. But now we have one more step. We have one more question. Which, how many excess reactant is left? Purposely they are asking you that. So now you don't have any choice. Now we have to work with this one. If you knew what is the needed amount is 0.48. What you have is 2 grams, so you subtract from 2 grams that value, and then the excess reactant will come there, which is 1.52. Is excess, inefficient, unused. Okay, have some minutes left. Let's see. very good. Oh, okay, there's one more thing, okay. There's one more slide here. One more slide, I can do that. This already, right? Yes, that's what I'm looking for. Huh? We haven't done that, right? Okay, that's what I'm looking for. Oh, here, right?
Yeah.
Okay, yes. We need to talk up.
One more thing. It's not a versatile person. It's actual maximum performance. It's still a consistent.
Why didn't you come?
Yeah, this one.
Okay. Okay, all right. Okay, all right. Here is what we can do. Percent yield. I want you to go back with experiment 6 from Chem 101 lab. Think about experiment 6 for a bit. Okay, well, experiment 6 actually was a quantitative type of analysis. It was finding the amount of copper from a solution, right, Tosi? The amount of copper from solution, right? What is that we did? No, just a simple reaction. We had copper reactors with sulfuric acid, for example. You get no, sorry. That was you have copper sulfate plus zinc or aluminum, based on your choice. Some of you have zinc, some of you have aluminum, right? You get zinc sulfate plus copper, or aluminum sulfate plus copper. We're not going to discuss about all the 6 steps. There are a lot of steps there. But I just want you to think about the idea behind it. What was the idea of experiment 6?
To get the copper back.
How do you get, okay, yes, that's a good question, that's a good point. How do you get the amount of copper? I mean, in terms of the amount, you start with point something grams of copper, right? You mix copper with sulfuric acid, you mix copper with nitric acid, you mix copper with sodium hydroxide. You did like 5-6 steps. You make reactions, the color changes, sometimes blue, sometimes black, sometimes brownish, sometimes precipitate, right? At the end of the day, you get what? You get the same copper that you started with, if you are careful, if you don't make mistakes. Whatever amount you start with at the beginning, you get the same amount at the end. What rule is behind this? What is the rule behind this?
Conservation of mass.
Law of conservation of mass, which is the Dalton atomic theory, right? Whatever amount you start with, you need to get the same amount. Now, the point is, how do you know you get the right amount?
Right, she's right. Like we just wait what we have, but we cannot find the same amount because we have used a lot of.
I know that. But the point is you waited, but how do you report that? By terming of what?
Use the pencil.
10 percentile. How many percentage do we get?
Good. Percent. You're going to compare the actual yield with the theoretical yield, right? You remember, you have the actual yield and the experimental yield. I gave you 0.51 grams. That is the recovered amount of, you recovered it. You made step 1, step 2, step 3, step 4, step 9, whatever. and then you have initial value that you started with, right? You're going to compare those two values. If your percentage gets you 100%, really, you're doing low conservation of mass is proof. Well, you got so many percent, for example, 80%, right?
Yeah.
When you do your experiment. I don't know, some of you get 90%, some of you get 89%, some of you get 99%. We have, of course, there are errors, human errors and everything there, right?
Instrumental.
And, well, instrumental errors, etc., etc. But the percentile is the ones that you report, okay? You report whether you really, you are accurate or you made a mistake. Everything over 95% is considered to be accurate because nothing is perfect, okay? But if you have below 95%, well, you have to give an explanation why you get less than 95%, okay? How do we do this? We have to do this by a percentile. Okay. Now again, for a percentile, it's very important to know about which one is a limiting reactant. You know, for example here, one of the ways they extract iron from iron ore, from iron oxide, they use carbon monoxide. When they add carbon monoxide into iron oxide, they purify iron here. We don't need carbon monoxide, we don't need iron oxide, but we need iron for many, many industrial purposes. We need pure iron. So extraction of iron from iron oxide needs carbon monoxide. You need the maximum amount of product. You need the maximum product possible. But one of these two may not be consumed equally. One of them can be a limiting reactant, the other will be an excess reactant, right? So how much iron I will get is going to be determined by the percentile here. So I have to think, I have to say, you know what? I have to add maybe the product of iron oxide to get more iron. I have to reduce the amount of carbon monoxide to get more iron. You see, this limiting reactant tells me what product should I purchase more, what product should I purchase less, or what product should I use more, okay? Now, it was given for you here. If you start with 150 grams of iron oxide as the limiting reagent, now you see everything is easy for you because you don't need to do the limiting reagent because it's already said here. Your limiting reagent is what? Iron oxide, iron 3 oxide, actually, that's the right name. Is 150 grams of iron 3 oxide. What would be the theoretical yield of iron? The theoretical yield of iron. The theoretical yield of iron can be calculated from the equation, not from the experimental determination. It is calculated from the equation. That's the theoretical yield. If you have 150 grams of iron, how much iron, if you have 150 grams of iron 3 oxide, how much iron would you get? You make a calculation, right? What is the ratio between iron 3 oxide and iron? It is 1 to 2, right? Which means, what is 1 mole of iron 3 oxide equals to in terms of gram? Iron is 56, by the way. So find the molar mass of iron 3 oxide.
160.
I'm sorry?
160.
160. So 160 grams of iron 3 oxide provides you how many grams of iron?
104.
160 grams of iron 3 oxide gives you how many grams of iron? 56 times 2, right?
It's
112.
112 grams of iron. So if you have 150 grams of iron 3 oxide, how many grams of iron you get?
120.
X would be 150 plus 112 over 160, which is 120 grams of iron.
Hold on.
And, huh?
I think I did it wrong.
Just
Sorry.
brutal,
Oh. Can I have a weakness?
105.
105.
When do you get one? What's the number grams of iron?
56 times 2.
But it's supposed to be like
So that's what I get from him. 1 moles of iron 2 oxide, 2 times 112,
That's 150, not 160.
112 plus 48.
160 is actually good.
Huh?
It's 160, yes,
So-
it's
so we would-
160 to see,
160.
160. right? Okay, 160 grams gives you 112. So 150 gives you X. So the amount of X is 105 grams of iron. That's theoretical yield. But the actual yield, when you do experiments, that is the experimental value was 87.9 grams, which is much less than the theoretical yield, right? So you need to calculate what? Percent yield, right? What is the percent yield? 87.9 grams divided by 105. Yes, 87.9 divided by 105. What do you get?
84 points.
84 points, less than 90%. Is it a good result? No, it's not a good result. A good result means like, you know, this is about money. This is about, you know, you have to have over 95% grade for that. I'm done with chapter 3 here. I'll give you an assignment, a graded assignment, and do you have the book? And I'll give you a test.